Just yeah. Okay, well, thank you very much. We have a pretty filled out room, so it's good to hear people are interested in this topic. My name is Sean Auden, and I'm going to be giving a presentation on BIM automation for quantity takeoff and data validation. So just a bit of background about myself very quickly. I'm a graduate from TU Dublin with a bachelor's degree in architectural technology. I'm currently working as an architectural technologist at Corgan. My key interests at the moment in this field is BIM automation. I have some interest in programming and artificial intelligence. And outside of construction and work, I enjoy traveling, weightlifting, all those things like any other person. So to give some context to what I'm going to be talking about, I'm going to answer the question of what are the methods for carrying out a quantity takeoff from anything. So this diagram should provide a kind of comparison between the two main methods I discovered. So with a traditional method, you would have your BIM model. It could be a house, it could be a commercial project, anything. Typically what the quantity surveyor or the cost consultant will do is ask the architect, okay, give me PDF drawings. I'll put it into Qubit or CostX and I will do my quantity takeoff from there. From there, they will do a number of processes, such as applying standard rules of measurement, which I'll get into later. But if we look at the BIM side, the BIM model will go through further detailing, going into the data within the model and such. You could have a way of automating the quantity takeoff and having it automatically put into a spreadsheet or whatever that could be used. But what is missing is that standardization before going into the bill of quantities, which is what I'm going to talk about. So my motivation going into this research is I previously worked as a project manager, and in that company there was in-house QSs. So as a student, I was able to very quickly gain insight into, I have a background as a designer, but what are the issues that quantity surveyors have with our current BIM models and how can we address that? Just to give some kind of statistics or kind of facts around the issue, it's well known that we're in a housing crisis and it needs to be addressed. The current traditional quantity takeoff method has been considered slow, manual, and error prone. 67% of Irish QSs lack BIM training in a previous study, while 74% lack in-house expertise, and so on. So in this research, which I completed as part of my dissertation and my degree, the objectives I wanted to reach or aim for were, first of all, identifying the inefficiencies in traditional and BIM-based quantity takeoff, which I briefly spoke about. I wanted to investigate a residential case study, which I'll talk about later. I wanted to develop a BIM workflow that would address this issue, the key thing being standardization. And I wanted to validate this through professional interviews in the industry and yeah. So what issue or the main issue did I come across? Because there's many issues in this area, but the main issue I came across is the information in a typical BIM model lacks the standardization that a QS will need to pull quantities from it. In the Irish context, we currently use, or quantity surveyors use, ARM5, which is the agreed rules of measurement, which is essentially how you measure the elements from a building and how things will be costed, etc. So my thought process going into this was, if there was a mapping file or some type of guide that us as the designer can use to put information into the elements in a BIM model, then have the quantities pulled from the BIM model into a schedule that is in line with ARM5, and have an ability as designers and QSs to quality assure this data, then the gap between the QS and the designers could be bridged. So the case study I looked into was a small dwelling based in Foxrock, County Dublin, which would reflect kind of the smaller issues that smaller QSs may face in our industry. The scope for this is to develop the BIM model to an LOG 300, which would be the typical level of detail that would be used for costing. I implemented ARM5 parameters into the elements, as you can see circled there. I added parameters into the walls, the roofs, which the designer could use to add the information that a QS would need, such as the work section, the element, etc. And I added intentional anomalies to the case study to test any anomalies or detection or like. So the video I play after will go into this in further detail, but that's the workflow it generally followed. I suppose the main thing going into this was that the main thing it will do is there will be a mapping file which is built around the ARM5 standards, which the designer can use to help input data into it. And then through the workflow, it will go through a similarity checker, which was through a Dynamo and Python script, which will essentially check the elements classification and the requirements in the ARM5. So what I mean by that is if you have a wall and in the ARM5 you only need the square meter, if you only need whatever. For a wall, you can pull linear dimensions, you can pull meter squared, you can pull volume, but for costing, you may only need one of them. So the idea behind this was that while it's going through everything, it's only pulling the one quantity that a QS really needs for this specific application. So this video will better explain it, I suppose. So you start with a BIM model setup, and in this case was the small residential case study. Each of the individual elements, as I explained earlier, have the shared parameters within them. Each element will have its own quantity, as we know. That's our shared parameters there. And these would be added from the designer would get assistance on how to add these through a mapping file, which we'll discuss later. The next step in this workflow was running a model checker. So I created this model checker through the use of Dynamo, and within Dynamo there's a bit of Python programming with it as well. So the user will run the model checker, and it's been built in such a way that if you don't have a lot of experience using Dynamo or you're not comfortable with it, it was made in such a way that there's a user interface that makes it very streamlined for the user. You would first be expected to select the mapping file, so that's the Excel file that has all of the information that the QS will use to classify each element, such as work section, element type, etc. And then you're simply selecting where you want the end result. So it's going to produce a spreadsheet of a schedule of all the quantities, which we'll see here in a minute. So this is what it will look like. Now, it looks great. We have loads of quantities, walls, roofs, etc., plasterboard. But looking at that, it's not really legible. You can't really take away anything from it. So the idea behind this was to have a dashboard, as you can see here, that the designer and the QS can use to quality check the data within it. So it will give a breakdown, okay, of all the categories within the model. It'll give a breakdown of, okay, what, from the ARM5, what classifications are being used. It'll also give you a breakdown of, okay, how many of the elements in the model are misclassified over which ones are correctly classified. So if we can see, okay, the designer has misclassified 10 of the elements or 20% of the elements, you can go back and change that. That's the general idea behind this. And it's in a format that's accessible for kind of any stakeholders to assess. So to validate this workflow, I conducted semi-structured interviews. So this is just a breakdown of it. There were 7 in total. 4 QSs and 3 ATs, one of which was a BIM manager, varying in experience and varying in industries, so you could get an idea of different backgrounds and different people's experiences, etc. So the first thing was the model accuracy and coordination. So they all felt that there's a big importance for model accuracy and coordination between projects, which is kind of something that is to be expected anyways. People found that the dashboard and the workflow was very helpful. They praised its clarity, but some had some issues over whether it could be further accessible or maybe easier to be used, such as this person who said only a few in the office would know how to run these Dynamo scripts, so there's a bit of work that would need to be done with that. I suppose the biggest takeaway would be is that you have the standardization, which is kind of the bread and butter behind this. QS here said you save time because the structure's already there. You're not trying to build something completely from scratch. The time-saving potential and the trust in automation. So as we can imagine, automation is a huge way to reduce workload, but you would need, especially the QS, you would need to build trust in this system in the first place before you start using it as an actual process within your office, I suppose. And then barriers to adoption as well. So what are the implications of all this research I completed? We had standardized outputs, which was a key thing. So you have your quantities for your walls, your roofs, etc. But it was missing the standardization, the classification specifically for them, which is what they were missing before. We have a visual dashboard, which is nice to look at and makes the whole process easier for people. Automation, as I mentioned again, and the process itself was made easy to use. But what were the barriers to trying to, let's say, implement this into a smaller practice or into a bigger company? There's a digital skills gap, which we are aware of. So in any office, you could have someone who's amazing at using Revit or using Dynamo, and then some that only know how to use AutoCAD and stuff like that. So there's that gap that would need to be addressed. Early buy-in would be needed. So it's all well and good me telling you this, but if you're to implement this workflow, I would really need to convince you as to go, okay, like within your project or within your profitability, where would you see the benefits? And cultural resistance as well. I suppose the big thing I got from the interviews on this aspect was me as a designer, I'm being paid to do drawings, do BIM models and such. Why should it be my responsibility to make the QS's job easier if I'm paying the QS anyways to do up the costing anyways? So it's trying to, probably from contract stage, get an idea of like, okay, how much responsibility am I taking on as a designer, and same with the QS. So if I was to recommend future research for anybody taking this on, this was on a temporary case study. It wasn't a live project, so this workflow would need to be tested on a live project that was happening and see how that would potentially affect accuracy and time saving. I would need to refine the classifications further. So ARM5 is a very metric, very complex document with loads of subclasses for very specific elements. Due to the nature of my time constraint, I didn't get to go through every single subclass that have their own rules. So refining that would make it more legible. And AI, being the buzzword in our industry at the moment, previous research has been done with doing this type of thing with AI, but potentially if the framework was built out enough, implementing AI into this could further streamline the process. Thank you very much.